Welcome you all to the week 3 problem solving session of Advanced Calculus for Engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. Today's session we start by recalling differentiability and differentials in one variable. Then we will see how they are connected and we extend this concept to two variables. And then we apply this differentiability to composite and homogeneous function y chain rule. So let us start by recalling what is differentiability in one variable. So
So can you tell the answer of last question?
wait, let me first write this, then I'll let you know.
Okay, sir. And I have one or two doubts from past topics.
Okay, we will discuss maybe after the class. Okay.
Okay, sir. Okay, sir.
So a function fx is said to be, STB means said to be differentiable at x naught if when x naught is given the increment delta x. Basically this is an arbitrary increment the increment delta y can be expressed in the form delta y as a times of delta x plus epsilon times of delta x, and here a is independent of delta x, and if we talk about b, if we talk about epsilon, then it will tend to 0 as delta x tend to 0. So whenever we have this kind of expression, in that scenario, if our this a is independent of x and this epsilon goes to 0 as delta x tends to 0, then we say our function f is differentiable at the point x naught. Okay, and this term is known as differential of this function, and it is denoted as dy. So this is the bigger change, or you can say increment in y, exact increment, and this is the approximation, you can say this is a linear approximation. So if you will try to rewrite it, so we rewrite dy as a times delta x, and this a is nothing but, if you will rewrite, then you will get f dash at that x naught delta x. Okay, so this was about the definition of differentiability at x naught. Now the next question arises, we cannot always apply this kind of definition. We can even directly see how the function is differentiable, or at in which condition the function differentiable. That means necessary, what will be the necessary and sufficient condition of a function to be differentiable at a point. So what it can be? Any guess? I'm repeating it. What is the necessary and sufficient condition for a function to be differentiable at a point? So let me explicitly write it.
So it should be continuous.
Okay. And
Necessary condition it is.
and so let me write it.
And slope of tangent in left hand side and right hand side should be equal.
See, I'm talking in terms of this derivative sense, this kind of sense, this definition sense. If I would say, suppose this is equation number star. So let me write it. The necessary and sufficient condition that the function y is equal to fx is differentiable at the point x naught is that it possesses a finite derivative at this point. So let me explain what does this mean. So we discuss the derivative that you are talking about, that was derivative, left hand derivative, right hand derivative, and how this derivative and differentiability related, that is this necessary and sufficient condition. You can say your function y is equal to fx is differentiable if and only if and only if your derivative, that means f dash x equal to some a, that is nothing but a finite quantity. So differentiability, the basic definition of differentiability can be checked with this definition given in star. And the other thing is that derivative. So derivative, if derivative is finite, you can say a function is differentiable, and the other way around also, if function is differentiable, then obviously derivative is going to be finite. This is the necessary and sufficient condition for this particular function to be differentiable at x equal to x naught. Okay, so now how can we extend this to two variable? So let me just mention one thing here. Delta y means obviously this is the exact change in f x after the increment of delta x. And the part, if we will rewrite like that, f f x can be written as, you can say, f of x naught plus x minus x naught into a plus epsilon times x minus x naught. And this part is known as linear function of x, or linear approximation of f around this x naught. Or it is also equation of tangent line at x naught comma f of x naught. So this was about in one variable. How this differentiability concept can be extended to two variable? differentiability in differentiability of two variables. So here it was differentiability of one variable. So let me just, so with this equation star, can anybody tell me what does the meaning of differentiability of two variable? I mean, how it will change, how it will affect in the equation? Any guesses?
In left hand side there is dependent variable
Yes.
like delta y, and in right hand side there is a constant a, which is the derivative and multiplied by del x. So
Hmm.
in two variable there will be a delta x plus b delta y
Okay.
plus epsilon 1 delta x plus epsilon 2 delta y.
Correct. This was differentiability of function in one variable, and now this we are going to discuss differentiability of function in two variable. Differentiability of functions of variables. So here the change as mentioned by Manas is that only that since there was dependency on only on one independent variable, here the dependency on two independent variable. That means earlier there was a two terms on the right hand side, here there is going to be four terms on right hand side. So the function z is equal to fxy is said to be differentiable at the point x naught comma y naught if at this point your delta z can be written as a times of delta x, b times of delta y plus epsilon 1 times of delta x plus epsilon 2 times of delta y. And similar to the previous saying where a and b are independent of delta x comma delta y, and what will be the case of epsilon 1 or epsilon 2? Epsilon 1 and epsilon
Limit
2 are functions of delta x and delta y. Which kind of function? Such that
limit
limit
delta x tends to 0, epsilon 1 tends to 0, like that,
delta x delta y
tends to 0 0.
tends to 0 0, in this
Then
case epsilon 1,
epsilon 1,
and also
epsilon 2 tends to 0.
whenever this limit tends to 0, your epsilon 2 also tends to 0. So similar to the previous one, here what will be the differential? This part is called as
Differential, total
differential.
differential or differential.
Yeah, total differential also we can say that dz.
A is partial derivative with respect to x and b is partial derivative with respect to y.
Correct, correct. Total differential. So here a is nothing but f x at x naught y naught, and b is f y at x naught and y naught. Okay, and this part is also called linearization of your z around x naught comma y naught. So this is the differentiability in case of two variables. Now what will be the necessary and sufficient condition in this case? So the necessary and sufficient condition in this case is as follows.
The
If,
function should be continuous
yes, and,
and partial derivatives should exist, fx and fy.
and that's all.
This was sufficient condition. No, no, this was necessary. Necessary.
Okay,
Continuous and fx and fy should exist.
so I'm writing in short point in point-wise manner. So necessary conditions is that first one is f continuity of f should be there. Second one is existence of partial derivatives fx and fy, and the sufficient one is sufficient conditions. First one is,
One should exist and other should be continuous.
that can be also a case, but
Yes, sir.
there is one more also, continuity of the partial derivatives. This is obviously the general one, and the weaker one is, or I'm writing is first only because we need only one of them. Existence of one partial derivative and continuity of the other. That means one should exist and one should exist and also continuous.
Mhm.
So this is your necessary and sufficient condition in case of two variables. Now let me write one question so that it will be clear. The total differential of the function zxy is equal to 2x cube plus 3xy to the power 4 plus e to the power y square is equal to ax square plus 3y square dx plus bxy cube minus cy e to the power y square dy. Now find the value of a into c plus b. So it's direct implication of the previous discussed definition. So try this one.
0, sir.
Correct. So let us do it. So what is the definition of the differential? Total differential dz is del z del x dx del z del y dy. So what is del z by del x? We know that zxy. So that means you need to differentiate with respect to x, keeping the other variable as constant. So this will be 2 into 3x square plus 3y to the power 4, and differentiation of x is 1, and the third term will be 0. So this will give you 6x square plus 3y to the power 4. In the same way, when you try to differentiate with respect to y, so obviously the first term is simply the variable in x, so it will be 0, and the second one is 3x into 4 times y to the power 4 minus 1 plus e to the power y square, and by the chain rule it will be 2y2 minus 1. So this will be 12xy cube plus 2y e to the power y square. So when we substitute these values in dz, we will get 6x square plus 3y to the power 4 dx plus 12xy cube plus 2y e to the power y square dy. Now what was the given value of this dz? This was given as a times x square plus 3y to the power 4 dx plus bxy cube minus cy e to the power y square. So if we compare the coefficient, so a will be nothing but 6. Second term, you can see both are equal. In the third term, b should be 12 and c should be minus 2. So when you try to calculate a times c plus b, this will be minus 12 plus 12, and your answer will be 0. I hope this is not that much difficult. So next is find. In this case, you need to find the total increment. Find the total increment of the function fxy is equal to x square e to the power minus y plus y square e to the power minus x at the point 0 0 for delta x is equal to delta y is equal to 0.1. Both increment in x and y are the same, so you need to calculate the total increment in the function f.
0.018, sir.
Correct, Manus? So let us do it. So we have given delta x, delta y, the point also. So f, total increment we have been asked. So that means delta f, or you can say delta z we have been asked. So this is nothing but f 0 plus 0.1, 0 plus 0.1, because both are the increment are the same in delta x and delta y, minus the actual value of f at 0, 0. So that means f at 0.1 comma 0.1 minus f at 0, 0, 0.1 whole square minus 0.1, 0.1 whole square minus 0.1 minus f at 0, 0. So obviously the both the terms has the multiplication of x square and y square, so this will be 0. So this will be 0.01, or in fact this will be 2 times of this, so this will be 2 times 0.01 minus 0.1. So this is nothing but 0.018. I hope it is clear. Now, as we have discussed the differentiability, so let us see how we can apply some given function of two variables. So for this, consider the function f from r square to r defined by f x y is equal to x cube sine 1 by y minus 1 whole square if y not equal to 1 and 0 if y equal to 1. So this is your given fxy, and let fx, so fx ab, so obviously you know that what is fx ab and fy ab. I'm not repeating it. So we need to discuss the differentiability or the existence of fx and fy at 0 1. So examine the differentiability. So since we are discussing differentiability, so obviously continuity is included inside. Differentiability of f comma fx fy at 0 1. So see how the function is differentiable or not at 0 1, and partial derivative exists or not. You know the main theorem, so try to apply that. So what is your answer? Is the function is differentiable? So first of all, if the function is continuous at 0, 1,
Yes, it is continuous.
so f 0, 1
I
is,
think my answer is Fy is not differentiable and F and Fx is differentiable.
okay, let's see. Second thing is limit xy tending to 0, 1 fxy. What will be this limit? Tending to 0, 1 x cube sine 1 by y minus 1 whole square. So this is a finite quantity between minus 1 and 1, and this is going to 0. So that means the output will be 0. So we can say that limit exists, and this limit fxy is 0, which is nothing but f of 0, 1. Therefore f is continuous at 0, 1. So this was the first necessary condition of f to be differentiable. What is the second condition? F to be differentiable? Partial
Fx and Fy should exist.
f and fx and fy should exist. What is fx01? Limit,
Sir, sir, I have a doubt related to that one limit.
yes.
Sir, in some lectures I have seen that where in sine or cos, especially in sine, I have noticed in denominator part, like the y is tending to 1, x is tending to 0, y is tending to 1, so the denominator is becoming 0. So sometimes, sir, it's saying we can't find that, so limit does not exist, and somewhere we say it is a bounded function, so it is exist. So I have one main doubt in this one,
See,
major doubt.
if there was no x cube, then we can say that our function, we can say that the limit does not exist. But here we have x cube in the multiplication, that is going to 0. So 0 multiplied by any finite quantity, we can say it is 0. Suppose there is no x cube. In that scenario, you can say that limit does not exist. Even if there is one x only, then also you can say that limit exists and it is going to 0. And here it is given as x cube. So we cannot comment about what is the exact value of this
Value
function
of
when y tending to 1. So that's why if we talk about this single function, then we can say that this limit does not exist. Okay, and whenever there is multiplication of any, specifically 0, I am not saying any finite quantity. If there is suppose 1, suppose x is also going to 1, then also in this case limit does not exist, because 1 into any non, or you can say you cannot commit what the exact value, finite value it will take. So 1 into anything that does that can be anything between minus 1 to 1, any number you cannot predict, limit will not be unique, as we have discussed in the previous class. So the benefit is here it is going to 0. That's the all benefit this limit is getting, and that's why this is existing. So let us calculate now fx at 0, 1. So this will be 0 plus h comma 1 minus f of 0, 1 divided by h. So this can be written as, so by definition this will come out to be h cube sine, what was your answer? Is it 0?
Mhm. Yes, sir. As y is 1, it will be 0 now.
So here, what we will write?
The definition of the function y is as 1. So if y is 1, the function is 0. So we can directly write it
Okay,
as 0.
okay. My bad. Sorry, my bad. That's what I'm thinking. So we have given that whenever y is 1, our function is 0. So obviously, in the both the terms, y is 1. So this will be 0, 0. So the output will be 0. So now we know that our first partial derivative is existing. So let us see the continuity, or maybe let us also calculate the second partial derivative. Then we will see the continuity of one of them. Limit k tending to 0, f of 0 1 plus h minus f of 0 1 divided by k. So this will be limit k tending to 0. So since our this first variable is 0 and this is 1 plus k, so we can use this definition, but since x is exactly 0, so the first term will be
0.
by definition 0, and obviously second one is 0, so this will be again 0. So both the partial derivative is existing, so the necessary condition of for the differentiability is satisfied, but it is not the sufficient. We need to check the continuity, or we need to guarantee the continuity of one of the partial derivative.
1. Yes, sir.
So
1 of them.
whenever this kind of question appears, just try to go with the polynomial one, this polynomial term, so that when we partially differentiate it, we will get the exact clarity of the differentiability of the continuity of the first partial derivative. So try to calculate fx xy in general. What will be fx xy? Obviously function is divided into two parts, so it will be remaining same, y not equal to 1 and y equal to 1. So obviously y equal to 1, it is 0, and
0.
when you will differentiate with respect to x, it will be 3x square
3x
sine 1 by y minus 1 whole
whole
square.
square.
So now obviously again with the same reasoning, limit xy tending to 0 1 f x xy is,
Continuous.
let us do it. So xy 0 1 3x square sine 1 by y minus 1 whole square. So again, this is a finite quantity and there is multiply some x, that is going to 0. So all over it is 0. This is fx at 0 1. So again, your fx is continuous at the point 0 1. So from this I want to comment one thing. Suppose if there was only x rather than x cube in the question, there was only x. So when you differentiate with respect to x, here you will left with only the term sine, as we have discussed earlier. In that
Yes,
case,
sir.
our function will not be this
Continuous.
not continuous at 0 1. So here,
So
hence, we have asked about the differentiability fx fy at 0 1. So obviously hence fx at 0 1 is 0, which is the same value fy at 0 1, and f is differentiable at 0 1 by the necessary and sufficient condition of the function. Now in the next question, that is a chain rule, z is equal to sine cube of x plus cos cube of y.
sir, we have to also check in that question about the differentiability of fx and fy. No? Let me see the question again.
No, differentiability of f, and I have to calculate fx and fy at 0 1.
Okay. I'm missing.
Okay, so you
Okay,
did
sir.
that also.
I was trying, but you have some doubts, and obviously, I'm seeing that
And
it is beyond BTech.
and value of fx and fy. Okay. So and x is equal to some function in u and v, comma y is equal to again a function in u and v, and we need to find the value of del z by del u minus del z by del v at u comma v is equal to 0 1. So can anybody tell me here why we use del z by del u or del z by del v? See, this is called tree diagram, or you can say. So z is
The
a function.
composite function it is.
You can also do by that, but I am telling you without doing composition. Then we will discuss that composition part also.
Okay, sir. Okay, sir.
So here z is a function of x and y, and again x is a function of u and v. In the same way, this is also u and v. So if you will directly say that, then z is a function of u and v. So obviously z is depending on ultimately on two variables. So there must be some partial derivative sense, that is del z by del u or del z by del v. This is one thing. So whenever you try to calculate del z by del u, so as I told you, this is depending on two variables. So it can be del z by del x and del z by del y. Now x is a depending on u and v, but you need to calculate only u. So this will be del x by del u and del y by del u. So I am saying that I am first of all coming with x, and then I am going to x to y. In the same way, y, then y to u. In now, if we need to calculate, suppose del z by del v. So how we will move? We will go z to x first, then x to v. In the same way, y, then y to v. So it will give us, so let me mention with that color also. Now about this one, so this will be del z, del x, del x, del v plus del z, del y, del y, del v. This is the chain rule you can say, and this chain rule I am applying via this tree diagram of this independent variable. The other thing is, you know that your z is some function of x and y, comma you know that x is a function of some g of uv and y is a function of h of uv. So what you can do, you can directly substitute at the initial stage that f is a function of g of uv and h of uv, and you solve it, and ultimately you will get some function of uv. So you can also directly differentiate with respect to del z by del u, keeping the other variables as constant, and del z by del v, keeping the other variable as constant, uh, except v. So this kind of any of the two approaches you can follow. So these two approaches I told you. Now you can try. what will be the value of this del z by del u minus del z by del v at this particular point.
Minus 3 by 2 sine 2.
Minus 3 by 2 sine 2, correct. So del z by del u, so it will be del z by del x by del u, del z by del y by del u. So what is the value of z? So for the first time we are writing it properly. Sine cube x plus cos cube y del by del u. What is the value of x? b e to the power u square plus del by del y sine cube x plus cos cube y del by del u of u e to the power b square. Now differentiate with respect to x. So this will be 3 times sine square of x into cos x. The other part will be 2 times of u v e to the power u square. Next one is 3 times of uh, cos square of y into minus of sin y, and this will be e to the power b square. So when you will try to calculate del z by del u at 0 1, so this will give you value. Obviously sine 0 is 0, so this part will be left only, and since we are putting it 1, so this will be minus 3 cos square 1 into sine of 1. Sorry, here u and v is 1, so we cannot substitute in this way. First of all, we need to calculate what is the value of x at u and v. What is the value of x at 0 1? It will be 1 into e to the power 0 square, that means this is 1. Y at 0 1, so this will be 0 e to the power 1 square 0. So we know that x has value 1 and y has value 0. So that means this factor will be 0, second factor will be 0, and this will be 3 sine square 1 cos of 1 into 2 times of 0 into 1 into e to the power 0 square. So this is ultimately going to be 0. Now del z by del v. So we know that del z by del x from the above expression, this is 3 times of sine square of x cos of x into del z by del v. So this will be del z by del x by del v. So in the next expression, this will be minus 3 times of cos square of y sine of y del y by del v. So this will give us 3 sine square of x cos of x del by del v of b e to the power u square minus 3 times of cos square of y sine of y del by del v of this is uv square. So this gives us e to the power square, and this will give us sine of y 2uv e to the power v square. Now we substitute uv as 0 1. Here also we should mention it. This is nothing but uv. So, and we know that x has value 1 and y has value 0. Therefore this will be 3 sine square 1 cos of 1 e to the power 0 square minus, this will go to 0, as y is 0, you can say u and v in v is u is 0, so this factor will go to 0. So your answer should be, what was your answer by the way? I think my answer is a bit different. 3 sine square 1 cos of 1. So del z by del u minus del z by
Sir, first bit is 0 and sine square 1 is. Oh, yes, 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 it is sine square 1. No?
Yes, this is sine square 1. So minus 3 times of sine square of 1 into cos of 1. Now let me give you one more question to check the
Three,
two.
3 sine 1 into sine 2.
Yes, you can see that.
Uh-huh.
Consider f r square 2.
Between them, there is minus sign. So
Yes,
one
with negative sign you will get your answer.
one sine 1 and cos 1 will become half of sine 2, and then we can just basic manipulation.
Yes, exactly. X plus y. If x plus y is not equal to 0, 0. If x plus y is equal to 0. We have given this function, then we then check the differentiability of f. Manas, can you mute yourself? F at 0, 0 and calculate f x at 0, 0 and fy at 0, 0. Do this one. This is similar to the previous one. Question number 3.
Sir, fx at 0, 0 and fy at 0, 0 is equal to 0. So my bad, 1, 1.
Okay.
And uh, sufficient necessary condition is fulfilled, but sufficient condition is not. So we have to go to the limit definition or something else, na sir?
Hmm. So sufficient condition is not fulfilled. Why?
Uh, fx or fy will not continuous at 0, 0.
Hmm. At 0, 0 or around 0, 0.
Oh, my bad. Around 0, 0.
Obviously, that both the meaning are same. So how will you check the continuity? Did you differentiate with respect to x or with respect to y?
Yes, yes, partially differentiated. Partially differentiated.
If
Then
you
we can easily see that in numerator we have 2 degree terms and denominator we have 1 degree terms.
yes.
And u by v rule, denominator will get a square. And
So
then denominator will get a square. We put y is equal to mx or something like this. The square terms, yeah, I mean the
but
variable term
first of
x or y will
first
cancel.
of all you
And
Manas, first of all you need to differentiate with respect to x. Then you can put that thing y equal to mx or something. First of all you
yes,
need
yes, I've done that thing, sir. I've done
okay.
that thing.
So and the other advantage is this function is symmetric about x and y. If you change
X
the
and y, yes, sir.
so
Hmm.
if you can check only one with respect to one variable, then obviously you can guarantee about the other variable also.
Other variable also, yes.
So let me solve this. So f x at 0, 0. So limit h tending to 0 f 0 plus h comma 0 minus f at 0, 0 divided by h. So this will be the case that comes under x plus y equal to 0, 0 or limit h tends to 0. So the first one will be h square plus 0 h plus 0, and this comes under the second case h. So this will give us value 1. In the same way, since you can say since fxy is same as fyx, therefore its partial derivative will be same. So next one is this is the you can say existence of partial derivative. Now comment over the continuity of the function f. Is the function is continuous?
No, sir. Function is continuous,
Then how
but
how
fx
function
and fy is not continuous.
okay, how function is continuous? Remember polar,
We can go with polar. We can go with y is equal to mx.
but y is equal to mx give you the non-existence of the limit. It cannot guarantee the existence of limit. This is only one path, one linear kind of path mx.
Yes, sir. We can then go with
We have to go with the epsilon delta then.
polar. Or polar we can also go, and epsilon delta we can.
So this will give you r cos theta plus sin theta. So as r tends to 0, so obviously this quantity will tend to 0. This is nothing but f of 0, 0. Therefore f is continuous at 0, 0. Next one is fx at xy. What will be this differentiation? So this will be, you can say, 2x divided by x plus y minus x square y square divided by x plus y whole square. If x plus y is non-zero, 0 if x plus y is 0. So this will come out to be x square minus 2xy, sorry, plus minus y square is the same you are getting. Manas, you were getting the same.
Yes, sir.
So now to see the, obviously the, you can say, now you can choose the path. Now you can choose the path because both the degrees are the same. So you can guarantee that x square terms will cancel out and it will be depending on m. And you can also go with the polar coordinate. Choice is yours. So you will go along y equal to mx. Since both the degree of the numerator or denominator is same. So limit xy tending to 0 0 fx of xy is equal to limit x tending to 0. So this will be x square will come out 1 plus 2m minus m square divided by x square into 1 plus m whole square. So this will be depending on m. Therefore fx is not continuous at 0 0. So obviously the sufficient condition is not satisfied. In the same similarly you can also say, because f is symmetry in the x and y, so fy is not continuous at 0 0. So since the sufficient condition is not satisfied, hence f is not differentiable at 0 0. So what if I would say to do this question with the, you can say, limit test, limit differentiability test. Did you know limit differentiability test?
Yes, sir.
So limit differentiability test says that del z minus dz divided by del rho, if this goes to 0, or you can say, let me write in the limit sense. So limit delta rho tending to 0, this going to 0. So the function is differentiability. So differentiability guaranteed with this thing also. Differentiability. So here del rho is nothing but under root of,
Del x square plus del y square, sir. No?
yes, del x square plus del y square. This is your limit differentiability or you can say testing differentiability. To do this, obviously we need fx at 0 1, fx at 0 0, fy at 0 0. Then only we can do this. So limit delta rho tending to 0. So what is del z? Let us first calculate these values. What is del z? F h comma k minus f at 0 0, because there is a change in h comma k. So what the output it will give? Tell me. This will give you h square plus k square divided by h plus k. So obviously the other term is 0, and you know that what is your dz? What is the
Fx.
fx
A into,
so this
we
will
can
be
go with fx
dx.
into del x.
So since we are denoting the small change with h and k, so this will be h plus k, or you may write it here. Let us follow that this del x del y. So this will be del x del y. So this will be del x square del y square del x plus del y. So this will be one time of del x, one time of del y. Now substitute these values in the above expression and you will get limit delta rho tends to 0 dz delta z minus dz actual change and approximate change divided by delta rho, and this is nothing but delta x delta y tends to 0 0, and this will give you delta x square plus delta y square divided by delta x plus delta y, and minus
Square root.
delta x minus delta y divided by under root of delta x square plus delta y square. So solve this one. What expression you will get?
The limit is 0, sir. We can go with in numerator side. We have to subtract. Okay, minus del x square minus del y minus 2 del x del y upon del x plus del y into root under del x square plus del y square.
So which has the
And
greater degree, numerator or denominator?
both degrees same.
Both degree is the same. So it is advantage or disadvantage?
Disadvantage. No, the limit will not exist. And obviously it
Yeah,
will not go to 0.
but it is disadvantage in that scenario, but advantage in proving sense. Okay.
Proving, yes, yes. In proving, it is very easy. It is very easy to prove that limit does not exist.
Yes.
And it takes a lot of effort to prove it limit will exist, the function is continuous, or
Yes.
it is differentiable.
So this will be
That's
1
what we are doing right
plus m under root 1 plus m square. Therefore, limit does not exist. And if this limit does not exist, hence test is fail, or you can say f is not. Obviously, test does not fail. F is not differentiable. We can
F is not differentiable. Yes, sir.
we can conclude with the test. If this limit is existing, then we can say that function f is differentiable. Otherwise, if it is not existing, otherwise function is not
Yes,
differentiable.
not differentiable. Limit should exist and it should be equal to 0. Then we
Yes,
can
it
say
should
that.
be equal to 0.
Yes,
So let me write the next question. Similar to this one, let f is a function from r square to r defined by f x y is equal to xy divided by mod of y if y is not 0, 0 if y is 0. Again we need to examine all the things, differentiability, fx, fy, then calculate fx at 0 0, fy at 0 0, and comment about the differentiability of f at 0 0. This is similar to the previous one, so it will not be that much difficult for you to prove it. Try this one.
fx at 0, 0, fy at 0, 0, both are 0, and the function is not differentiable at 0, comma 0.
Okay. So limit xy tending to 0, 0 of fxy. I'm doing by polar coordinates. This will be r square cos theta sin theta divided by r into sin theta mod. On r there will be no mod, because you know that r is a distance or radius, you can say, so it is always positive. So the factor or the mod will work on only the theta type of terms, so it will cancel out and you will left with r tending to 0, r cos theta sin theta divided by mod of sin theta. So this will 0, that is nothing but f of 0, 0. So f is continuous at 0, 0, and fx at 0, 0 will be limit h tends to 0. This was xy divided by mod of y, so this will be f of h comma k minus f of 0, 0 divided by h. So this will give us limit h tends to 0. So the first term y not equal to 0, then only we consider for this one. So here I made a mistake, this should be 0. So this will be 0 minus 0 divided by h, this is 0. What about f y at 0, 0? So this will be limit h tends to 0 f 0 k minus f at 0, 0 divided by k. So this
Again, numerator 0, x is multiplied.
x is multiplied, so this will be 0 into k divided by mod of k minus 0 divided by k. So this will give us value 0. Now to check the differentiability, either we can go with the differentiability test or we can directly differentiate. So if we do fx of xy, so this will give us y by mod y. This is simply looking like that this should not be continuous. Okay, if x if y is not 0, 0 if y is 0. Now tell me, is it continuous? Limit xy tending to 0, 0 fx of xy,
Not continuous, sir.
not continuous obviously. So fx is not continuous, so I'm writing directly. What about fy? What about fy? Can we differentiate with respect to fy? First of all,
It was also, I think, not continuous.
okay, so how we can guarantee that? But see, if you write this one y greater than
We
0,
have to, yeah, we
y
have to
less than 0,
redefine and then x and minus x, and then 0.
so fy of xy.
Not differentiable, basic mod function. Acting like
Are
this.
you sure?
Negative to minus x. Wait a minute, sir. Y is equal to x, y is equal to minus x, L 0. X. Yeah, it is not differentiable at 0. Continue. Oh, sorry, sorry. Oh, sorry, sorry. We have to talk about only continuity on that way. It is continuous at 0, but not differentiable at 0. So Fy is 0, 0 for all y.
Now if I would say to check with the limit test, I'm writing delta x and delta y as h and k for
So
simplicity.
sufficient condition is fulfilling that now continuous at 0 0. So a function will differentiable.
We are just cross checking it.
Okay, sir.
Minus, so limit hk tending to 0 0. What is del z? Hk divided by mod of k minus 0. You know that fx is 0, fy is 0. So this will be 0. H square plus k square. Can we apply polar coordinates? Obviously yes. R square cos theta sin theta divided by R mod of sin theta into R. Limit R tending to 0. Directly I can write cos theta sin theta, but from this it is coming out to be not differentiable. Did we make
Yes, sir.
some mistake?
Yes, sir. I think so. In FY, we can check. I am getting both are not continuous.
Okay, why Fi is not continuous?
Wait, sir. Wait, sir. Let me redefine it. So let me see the question once again.
Okay,
You can check for fx. We have to define for fx partial differentiative expression 2x 1. But why? What a why? Sir, if we redefine the function,
hmm.
if we redefine the function as y positive, y negative, and y 0, y positive, y 0, y negative. If y is positive, it is x, y is 0, it is 0, y is negative, it is minus x. And this is all about function f of x, y. So, yes, it is continuous. Doing some mistake.
Then
Okay.
what the mistake we are making in this particular approach?
0 to infinity, wait. 0 to infinity, domain. Ah, domain is 0 to infinity.
Sorry,
Function is only defined in the right hand side. Domain is r square, sir. Domain is r square.
hmm.
Range is r.
Okay, so
So domain is 0 to infinity.
why do you saying that domain is 0 to infinity? I mean, we are
R
considering
square means that one. Na?
r square means r into r. That means x can take any real number, y can take any real number.
My bad. Okay. Why it is not equal to 0? If y not equal to 0, then this is x, y positive x, y negative minus x. Function will reduce to some. Yes, sir. Yes, sir.
Yes. Did you get any?
Uh, yes. For fx, I mean partial derivative with respect to x, we have y upon mod y. which is obviously not continuous. Modulus function will give 1 and minus 1.
Okay.
When we and for fy, we are just redefining but not differentiating. If we differentiate for fy, we did redefine as y positive pay x. Y positive, the function will x, y is 0, function is 0, y is negative, function is minus x. And we have to find fy. So partially differentiating with respect to y. Oh, no, it also becomes 0, na? For all y belong to
Yes.
0. No. Negative x. Differentiate with respect to y. But y positive is positive. Partially differentiating. Not coming to any conclusion, sir. I can't conclude anything. Hello.
Just a second.
Okay, sir. Okay.
See, if you remember in the earlier class, I told someone that we cannot differentiate directly without knowing the what is going to happen in the neighborhood of f. Okay, so obviously this cannot be guaranteed until we know that f is continuous in neighborhood of 0 0. I am saying that because calculate f by x0 where x is any non-zero quantity. Obviously this number is in the neighborhood of 0 0.
Understood, sir. Understood.
So in this
A
case,
limit test is showing the proof that the function is not continuous.
yes,
So we can cross check by any method, sir.
this will be
I
f
can
by
understand.
x comma k k minus, oh sorry, f at 0 0 divided by k. So this will give us limit k tending to 0 x divided by mod of k. So obviously this does not exist. So if this does not exist, that means fy is not continuous. Can we say that?
Yes, sir. Yes, sir. Obviously, we can say that.
In neighborhood of 0 0. So obviously it is not, if it is not continuous in the neighborhood, so that means it is not even continuous around 0 0, you can say. Okay, hence f is not differentiable at 0 0. So sometimes if you get confusion, you have that test also that you
Yes.
can apply. So this
Yeah.
is the
Final
best,
limit test.
yeah, this is the best example that shows that your partial derivatives are existing, function is continuous, still the
Uh,
function is not differentiable.
Not different. Sufficient conditions are fulfilled.
No, sufficient conditions are not fulfilled. If those are fulfilled, then obviously function should be differentiable, na? There is one.
Oh, yeah. Yes, yes, yes. Understood this.
So next,
One more
let
example. An Euler theorem, maybe.
r square, sorry,
This is the last example. The time is ending.
um, I have some more also, but let us do this one first.
Okay, sir.
X square y minus 1 whole square mod x plus mod y minus 1 not equal to 0 1 0. Then calculate fx at 0 1, fy at 0 1, and check the differentiability of f at 0 1. Quickly do this one. It is not appearing now. Okay, I'll write this one again. Question number 7. Let f be a function from r square to r defined by x square mod x 0. Then calculate f x at 0 1 fy at 0 1 and check the differentiability of f at 0 1. Quickly do that.
fx 01, fy 01 is 1 1,
Hmm?
and function is not differentiable. I'm directly going with the limit test after checking the uh,
So
continuity. Just
according to you, partial derivative is existing.
yes, sir. Fx and fy at 01 is 1 1 existing.
Okay. What if I would say it may not exist?
Mm, these are some portions where I found difficulties, like mod and the one I told you that in that way, and then limit some parts where after rationalizing and all, some things are changed in some basic questions, like some more twisted questions. I have a doubt. I will ask in next class or whenever you allow.
Okay.
After rationalizing, the form is changed, and I am not clear with
Okay.
which form is.
Let us see here what is going to happen. H square divided by mod h minus 0 divided by h. So this will be limit h tending to 0 h by mod of h. Then how did you say that it exists? I hope you understood my point. Is it clear, Manas?
Yes, sir. Clear, clear, clear.
So
So
therefore,
I was doing with that one direct shifting. Y minus one is equal to t, but it is
in that case
misleading
also,
me in
in
checking
that case
differential.
all, in that case also, I can say that it will not be like fy at 0 1 will not exist also. Okay, you can check that.
Okay, maybe I've done something wrong.
What about continuity?
I think the function is continuous.
The same way you think the partial derivative
I
exists.
I think I think I'm wrong.
So
Maybe I'm wrong.
in this case,
But the function is not differentiable.
in this case
And
your polar coordinate will be like this. Here will not be y, it will be y minus 1. You just
yes, sir. Yes, sir.
need to remember this one. R
Done
square
this thing.
divided by r into mod of cos theta plus mod of sin theta. So obviously one r will be there, so this should be go to 0. This will be f 0 1. So f is continuous only
Continuous. Yes, sir. I'm right.
at 0 1. By luck, you're right. So
Maybe I'm done some mistake in that one.
there are some more questions related to this partial derivative sense. So let me write one for homework, then we will discuss what you were asking for. Question number, this was 7. Question number 8. Consider the function f from r square to r defined as fxy x cube if 0 0 0 then calculate and check the differentiability of f at 0 0. So now you can ask your doubt.
Sir, first till the la- answer of last question, last class question, like d2 f upon del x, del square f upon del x into del y and del square f upon del y into del x.
Hmm. This answer is C. Both do not exist. Both the
Both.
double partial derivative do not exist at 0 0.
Okay, sir.
Any other doubt?
Let me check
Yeah,
first, sir.
please check.
Sir, that one I asked, you tell told in few minutes ago, but I will ask in that detail after scrolling previous lectures once again, revising and seeing the notes. Then
Okay,
I can come particularly with the question that in this question this happened, this question this happened.
okay,
Then I will ask it again.
okay,
And one doubt I have in limit, but sir, now I have to go somewhere, and
okay, okay.
I'm feeling little bit hungry, sir.
So, okay, then
I
that's
will
all
ask in
for
this class.
today's session. We will meet in the next on the next Tuesday at the same time.
Okay, sir. Thank you, sir.
Thank you.
Sir, next class we will start with Euler theorem. No? Here we missed.
Sorry.
In next class we will go with I think week four. Week four, yes, week four.
Yes.
Euler theorem and all. Taylor's theorem.
Yeah, yeah. Taylor's theorem we will discuss in the next class.
Taylor theorem, yes, yes, yes.
Yes. In the Taylor theorem, week 4 lecture includes this Taylor theorem and maximum
And
minima.
a maximum minimum. But week three we have missed with Euler theorem. Euler
So
homogeneous.
you mean Euler result?
Yes, I remember, but few good questions, one or two good questions in next class.
We
I
may do that in the
it will
next,
be
maybe in the next class. By the way,
yes, sir.
it is not that much difficult. It is like okay, we can
Yes,
do.
sir. Yes, sir.
Let me just write then one question with the Euler,
Okay, sir. Okay, sir. It will be good for practice.
if you are saying so. I missed it. So let f is a function from d to r where d is equal to xy from r square such that x is positive, y is positive, be defined by fxy as cos pi by 2 e to the power pi by x minus 1 plus x square y sine pi by 3 e to the power x by y minus 1. Then find the value of fx at 1 1 minus fy at 1 1 divided by f at 1 1, right? So let me write the statement of Euler's theorem. If fxy is a homogeneous function of x and y of order n, then y and z, here this homogeneity mean homogeneous of order n means f of rx, f of ry will give you r to the power n of f of x comma y. Now you need to check whether your function is homogeneous, and if it is homogeneous, of then of which degree it is homogeneous. So whenever
So
you,
the term present inside cos or sine is not homogeneous, na? E to the power that one.
yes, yes, it will cancel out, r cancel out. So if you will check, this will give you r to the power 5, in fact r to the power 6.
3,
So
degree 3.
3 will come out under root x to the power 5y, and this will be cos pi by 2 e to the power y by x minus 1. This is in the angle, plus again r cube, this will be x square y sine pi by 3 e to the power x by y minus 1. So this will give you r cube of xy.
Yes, sir, we will do it.
Therefore f is a homogeneous function of order 3. Then by Euler's theorem, but you know that x times of this del z by del x plus y times of del z by del y, this is nothing but 3 times of z. Now what you need to calculate, you need to calculate fx at 1 1 plus fy at 1 1 divide f at 1 1. So if you will substitute x and y equal to 1 in this, put x and y equal to 1, then what will you get? This is the beauty of Euler's theorem. The question was looking so much tricky, but when you applied the Euler's theorem, it get to the easiest one. I hope it is clear, Manas. So,
Yes, sir.
okay.
I was just looking for question, not for whole solution, sir.
So this was question.
Okay, sir.
So
You have solved it, sir. Till answer. Okay, sir.
this is question number 8 is for your homework.
Okay, sir.
That's all for today. Thank you.
Can you tell the answer of question number 8, sir? Can you tell the answer for question number
Question
8?
number 8. Okay, let me tell you. Question number 8 is x cube. So this function is differentiable at 0, 0.
Okay, sir. Differentiable. And fx at 0, 0. And fy at 0, 0
Wait.
values.
I'm sorry.
I
This
think.
is not differentiable at 0, 0.
Okay, not differentiable at 0, 0.
Not differentiable at 0, 0. And you can check the continuity. I hope it is directly
Okay.
visible. It is continuous or not. But it is
This is where
definitely
it is
not
square by
differentiable
2.
at 0, 0.
Okay, sir. Continuous. Yes, it is continuous at 0, 0. I think
Yes.
tending to 0. Yes, it is continuous. Okay, we can check. And fx at 0, 0 and fy at 0, 0, sir.
Fx at 0, 0 and fy at 0, 0. So fx at 0, 0 is 1 and fy at 0, 0 is 0.
Okay, sir.
Okay.
Thank you, sir.
Yeah. Thank you.
Now we can go, sir.
Yeah. Yes.
Thank you, sir.
Thank you.